Good morning. Myself Akash Mahajan from TY Electrical. Our control system CI activities. The topic is using root locus technique. Design PD per PID control to place pole in desired location. Simulate step response to verify improvement in overshooting, sliding time, and steady state error. Presented by Rushikesh Pagire, Siddharth Sendkar, Dheeraj Shirsagar, Akash Mahajan, and Vedant Suralkar. And our guide is Dr. Vijay Kumar sir. These are the contents of our PPT and our topic. Introduction, overview, methodology, simulation block diagram, simulation result, advantages, disadvantages, application, conclusion, and reference. Introduction. Control system is essential for stable and performance in uh, engineering application. Root locus is a graph method to study movement of system poles with gain verification. The control system is a very important term in the engineering. By the control system we can control various devices. It helps in analyzing and designing stable system control. PD and PID controls are used to improve system response. PD and PID are used to improve the system response. Steps response is used to evaluate important in overshooting, sliding time, and steady state errors.
So this is our methodology. The given system transfer function is a first define the root locus, plot to study pole development, design a pole location are selected based on performance requirement such as settling time and overshoot. A suitable PD or PID controller is then designed to shift the pole of this location using the root locus technique. This control parameter are determined and closed loop system is simulated in MATLAB. Finally, the step response is analyzed to verify important in system performance. We are defining the two controller PD and PID controller uh, using MATLAB simulation.
Hello everyone, our CI topic is the using root locus technique design P controller, PI controller and the PID controller to find out the poles and the steady state stability of the system. So let's see how we will done the simulation using MATLAB software. So to go to the Google and search the MATLAB online and log in your account and go to the simulation blog and then go to the after that, after simulation you in front of you create a blank model in front of you. So go to the library browser and that to search the component that we use in the simulation. So go to the library browser and take the component. So we have your search step. So this search step is get yes. So this is the get signal and you have search the sum. Then you have go to get this block and connect this block to the step to the sum using the wires and then uh, uh, search the gain component in this search bar. So you have get this gate terminal and the name of the gate terminal is this is the KP. Enter the KP, enter the name, and the value of this gain is the here is the 5 value given is the gain. So join this component to the sum to the this gain terminal, and then after that you have search here the sum block. So the you have go get to the sum. Here is a sum. Drag this component, sum component here. So the connect this sum terminal you have changed the polarity using the list of signs. There is the 3 plus plus signs, so you have put the type the 3 plus plus sign there. So after click OK, so you get this sum terminal. After that you have to produce the signal to go to the saturation box. Here that search the in library of the saturation box. So we have get this saturation blocks. Connect this saturation block to the sum terminal. So after that you have get to the integrator. So the search bar in the search the integrator component. So you get this component, you get this component. So after double click of this component, you have put the value. Here we have put the 1, 6 and 10 in this equation form. Here is the 1, 6 and 10, the value you have getting. So the in denominator you have 1, put 1071. Here 1071, you are getting value. After click apply and click the OK OK. So you will get this, and the name of this block is the plant one, means controlling the plant using PI controller. So after that you have search in the search bar max mux demux mux. Here is the search demux. So you will get this blocks. So click this terminal to and join this terminal to the mux terminal. Mux terminal. After that, we have go to the design the eye controller. So the search in search bar search the integrator component. So you get the integrator. So click this integrator to the parallel to the system, and then you have search the gain terminal. So you have go to the get to the gain terminal, and this gain terminal is the value is the put the 5 as an given gain value. So click OK and click this gain terminal. So click here this terminal to the positive sum, and after that you have designed to the uh, derivative terminal, derivative D control PIDP controller. So then go to the search bar and search the derivative terminal. Here you have got get this component and drag here, simply drag this terminal. So you have get this terminal. So this terminal is also this component is also connecting parallel to the system. So here is the and also get also the gain terminal is also there. Drag this component to the simulation. So the value of the gain terminal is the 0. We have put the 0 value. So okay, click OK, and click this PI controller to the parallel to the system. After that the PID controller. So search here PID controller. PID after that searching you have got this term this component PID controller. So one sum is required to join this PID controller. So after join this parallel also, and join this PID controller to the system, and after that you have to one plant using control this plant using the PID controller. So the value is same as this plant of this plant is the 1610 and the 1071. You click apply and click OK. So your plant is ready. So click this connect this terminal to this controller, and connect this terminal to the mux terminal. Okay, so after that, you have go to the you have given the system feedback to the give the sum of integrate. So the here is the feedback controller. So give feedback to the sum of the controller. So after that, here is also give feedback to the this controller. This marks connect this terminal to this. After that, you have go to the search bar and search the scope. To visualize the waveform of the our system, you have to use the scope. Enter. Here is the scope. Drag this component to this simulation. So the here we have required two scopes to visualize the waveform. Here connect this scope to the this terminal. Connect, and this scope connect in the parallel with the here saturation. This is our overall simulation of the using root locus technique to design a PI controller and PD controller. Here are the stop time of the system is the 20 seconds. So the given 20-second stop time, and run this simulation. So see how will waveform generated. Double click to scope. You have to observe the visual waveform. So the see here the waveform of the controller. The blue line is PI controller, and the red line is the PID controller. So the find out the stability of the system using this controller. So this is our visualized waveform. And this scope is the this is our step response waveform. Thank you.
So this is our simulation. There are two graphs. First graph is a PD and second was a PID controller. So PD controller in this graph shows that the reduced oscillation compare. So this is our simulation result. So first graph shows that the PD controller, and second is the PID controller. So PD controller shows that the reduced oscillation compared to earlier, and so this PD controller smooth response faster. The in this PD controller is a faster response, and his settling time is also fast, and this is a stable controller signal, and this red line shows that PD controller, and second graph is showing a PID controller. This graph shows compare control signal before and after turning. Two curve indicate different control setting to improve controller, produce less oscillator and control action. This signal control show higher fluctuation indicating and inefficiency. So these two graph shows PD and PID controller.
So myself Vedanta Tatri Surakar. So I will explain the advantages. So improve system stability and overall performance, reduce overshoot and settling times. As third advantage is minimizes the steady state error, as it also provides the better control over system dynamics, as root locus offers a simple graphical design approach. So it is a means simple graphical design is there, as suitable for wide range or control system application. Means the locus system is used for the wide range to control the system applications, as uh, third and some disadvantages also are there. Rotos locus method become complex for higher order system, as some disadvantage, locus method is very hard and complex for the order system, requires accurate mathematical model of the system, as it requires the accurate and एकदम correct order of the mathematical model of a system. And third, trial and error is often needed to select the controller parameters. So too much errors are there to select the control parameters. It is also there. PD controller cannot eliminate the steady state error completely. Means the PD controller cannot eliminate the steady state error completely. PID controller tuning can be difficult and timing consuming as a sensitivity to the system parameters variation and disturbance. As okay.
Application used in power system control and stability improvement, applied in industrial automation and process control systems, used in motor speed positions control, applied in robotics for precise motion control, used in aerospace system for flight control and stability, applied in automotive system like cruise control and braking systems. And last one is conclusion. The root locus technique provide an effective way to analyze and design control systems by observing pole moment using PD and PID controllers. The system performance can be significantly improved in terms of overshoot, settling time and steady state error. Simulation result confirm that design controller achieve the desired specification, making the system more stable and efficient. Additionally, the study highlights the importance of proper controller turning for achieving optimal result. The PD controller improves transient response while the PID controller enhance both transient and steady state performance.